This video is about sockets and ports, which are transport layer concepts for TCP and UDP. In the figure, we see a TCP connection. On the left, there is an end system that implements all 7 OSI layers. Internally, there are processes, and the processes can be linked with ports. You can regard ports as virtual interfaces. For example, there is the web browser process, which is linked to the port number 12345. The so-called socket is the combination of the IP address and the port number. In between the two end systems we find networks. Please note that routers or other intermediate systems on lower layers have no knowledge about the transport layer. Therefore, the TCP connection is a connection between application entities on two end systems. In the end system on the right side, there is a web server process which is linked to port 80. To summarize the contents of the previous slide, a data stream on the transport layer is identified by 5 parts. The source socket consisting of source IP address and source port number, the destination socket consisting of destination IP address and destination port number, and the used transport layer protocol. Please note that the word connection for a data stream is only appropriate for TCP. UDP is not connection oriented, so that there are no UDP connections. On this slide we see an example of two end systems which have TCP connections towards the server. You can distinguish between these TCP connections only by the client IP address and port number. The server IP address and port number, as well as TCP as protocol, are the same for both connections. In addition, there is also the possibility that you can distinguish between TCP connections only via a port number. If a client retrieves a web page by using parallel TCP connections, which is typically the case, then you can only differentiate between these connections by the client port number. Among the port numbers, there is a distinction between different ranges. The ports 1 until 1023 are the well-known ports. For these ports, there are agreements which services are typically available using these port numbers. Please note that these agreements hold only for the server side. If you retrieve a web page with your browser, the port 80 is used only by the server. You, as a client, select higher port numbers by random. Apart from the well-known ports, there are the user ports which can be registered at IANA for server applications but may also be used by clients. Finally, there are ports which are only intended for client use. On this slide, you find some selected well-known ports. The port numbers 20 and 21 are reserved for the file transfer protocol. Port 21 is used for connection control. This means that the client tells the server what it wants to do via the connection to this port. The actual file transfer happens via the other connection to port 20. The ports 22 and 23 are used for applications where you do a remote login into another computer. The telnet protocol should no longer be used because it is insecure and does not do encryption at all, including the passwords. SSH is a secure alternative. The ports 25, 110 and 143 are used for email protocols. There are also additional ports if these protocols are combined with transport layer security. The domain name system uses port 53 typically via UDP. DHCP is based on the UDP ports 67 and 68. An official list of port number assignments can be retrieved from IANA, but there are also often unofficial uses. It is important to understand that this is just an agreement. If you want to configure on your computer an SSH server on a different port than 22, this is technically feasible and increases the security to some extent because only you know this assignment. However, it is certainly not a good idea not to use port number 80 for running a web shop. Then customers have difficulties to find the web shop.